Hello, this is Mr. Stansbury. I'm going to take you through the 7B notes on gradient, which is also the same thing as slope. At the end of this, you should be able to say that you can find the gradient of a line given the graph or coordinates of the points, and then also know the gradients of parallel and perpendicular lines. Alright, so let's start off with gradient. Okay, so the steepness, or again, key thing in here is that it's just the slope of the line. So if you remember, slope is rise over run, which is y2 minus y1 over x2 minus x1. Now again, that's just our slope formulas. So on this here, find the gradient or the slope of each line segment. So what I always like to do is I always like to start on the left and go from left to right. So if I start right here at this point, I go up 1, 2, 3, 4, 5, 6, it looks like, and then over 1, 2, 3, 4. So for A, it's going to be up 6 over 4, which is 3 halves, or 1.2 for A. Alright, for B, I'm going to start here and go down 1, 2, 3, and then over 1, 2, 3, 4, 5, 6, 7, 8. So down 3 over 8, and again that doesn't simplify, so that's your slope for B. For C, start on the left, go to the right, it's up none, and then over some number, so 0 over anything will always give you 0. So if it's a horizontal line, it's just got a slope of 0. And then for D, to start on, I guess, either one, since they're both, either one of them is the left-hand side, start with one and go to the other. There's no, well, let's see, the rise, we could say, is up 1, 2, 3, 4, 5. And then the run is 0, and we know that we can't divide by 0. If you do that, the world explodes. World explodes. We don't want that. Yeah, that's a picture of the world exploding. Of course, I mean, you can tell that, right? So, can't divide by 0, so that is undefined. Right? Okay, let's take a look at some other examples here. Let's find the gradient of the line through 3, -2, and 6, 4. So again, you can put this into the formula, which is y2 minus y1 over x2 minus x1. And if we did that, here's our, let's call this the first point, so this will be x1, y1, x2, y2. So if we're going to plug that in, we would put 4 minus, and then we have -2, all over x2 is 6, and then x1 is 3, so 6 minus 3. So that turns into 4 plus 2, so it gives us 6 over 3, which is 2. Okay, so that's, that's one way to do it. Another way to do it, the way that I like to do it is I like to do it without the formula, and I just remember that I always start with the farthest rightmost point, and I do this. I go 4 minus -2 over 6 minus 3, which again gives us 6 over 3, which is 2. Okay, so either way you get the same thing. Whichever one you want to do is fine by me. Alright, let's take a look at parallel and perpendicular gradients. Alright, so if two lines are parallel, their gradients, and again remember gradients is the same thing as slope, they are the same. And if they're perpendicular, their gradients are the what you call opposite reciprocals. Excuse me. So for example, if the gradient for perpendicular, let's say if the gradient of the original line was, say, 2, the opposite reciprocal, the new perpendicular gradient, which is an upside down t, is perpendicular. The perpendicular gradient to that would be, instead of 2, think of that as 2 over 1, Now it turns into 1 over 2. So we took the reciprocal, and then you also have to take the opposite of it. So it would be negative 1/2. So that would be the perpendicular to the slope of 2. Alright, so with that, let's take a look at an example of that. Okay, so given a line here, y equals 2x minus 7, find the slope of the line that is parallel. So the slope of the parallel line is the exact same as the original. So parallel slope, m equals 2. Perpendicular, oops, we just did that one over here. Again, if it starts as 2, the perpendicular slope would then be, again, flip that 2 over 1 over into 1 over 2, and then switch the sign from positive to negative. And then, obviously, if it was negative to start with, it would turn to positive. Alright? Okay, let's take a look at this. A little bit different. Find A given the line joining A and B is at A, negative 1, and then B is at 2, 3, and it has a slope of negative 2. So, back to our formula, m equals y2 minus y1 over x2 minus x1. So again, here's our first point, so let's call it x1, y1, x2, y2, and then again here's our slope of negative 2. So let's just plug in all of our numbers and see if we can figure out what a is. So m is negative 2 equals, that does not look like an equal sign, that's better, and then we got y2 is 3 minus y1 is negative 1 all over x2, which is 2, minus a. Alright, so now that we have this, I'm just going to put this negative 2 over 1, and then I'm going to do cross products to figure out what's going on here. So I'm going to do this times this should equal this times this. Alright, so we get negative 2 times 2 minus a should equal 1 times 3 plus 1, because the double negative turns into positive. So this here, if I distribute the negative 2 through, I get negative 4 plus 2a equals, and that's just going to be 4. Add 4 to both sides. 2a equals 8. Divide both sides by 2, and we get a equals 4. Alright? Okay. Moving along. Find t, given that the line joining D to C is perpendicular to a line with gradient 2. So again, if it's perpendicular and the slope is 2, our new slope, our perpendicular slope, is going to be, take 2 over 1 and we got to flip that over. So it's 1/2, and now it's negative. And then it's exactly like what we just did on the previous example. So if that last one made perfect sense, then feel free to skip forward to the last example. Okay, but I'm going to show this really quick here. So again, our formula m equals y2 minus y1 over x2 minus x1. So in this case, y2 is t. Oh, I guess let's start with m. Our new slope is negative 1/2. And then t is our y2. And then negative 3 is our y1. And then 1 is our x2. And then negative 1 is our x1. So this is just negative 1/2 equals t plus 3. And then 1 minus negative 1 is just 1 plus 1, which is 2. So again, I'm going to cross multiply and then solve. So we got negative 1 times 2 is negative 2. Should equal 2 times t plus 3. Alright, so negative 2 equals, I'm going to distribute this through, and we get 2t plus 6. So then I'm going to subtract 6 from both sides. Negative 8 equals 2t Divide both sides by 2 and we get t equals -4. So that's what that would be. Alright, one last example. Show that the following points are collinear. And again, collinear means all in the same line. Okay, so to show that they're all in the same line, as long as we show that the slopes between any two sets of these are the same, then we should be in business. So let's try that. 9 minus -1 over 6 minus 1 gives us 9 plus 1 is 10 over 5, which is 2. And now I'm going to try it with a different one. So I'm going to say do 3 minus 9 over 3 minus 6 gives us -6 over -2. -3, -6 over -3 gives us 2. And since these two match, that means that they have to be on the same slope. So all these points have to, between all the points, the slopes are the same, so that means they all have to be on the same straight line. Okay, so you should now be able to find the gradient of a line given the graph or coordinates of the points, and then you should also know that the gradients of parallel and perpendicular lines. All right, if you have any questions, please ask. Thanks.